assembly language program of 8051 microcontroller. The problem statement is write a program to move a block of 5 data starting from RAM 40H to external RAM memory 3300H onwards and perform complement operation before storing to RAM. Okay, first read the statement and try to get the logic. Then think what is the logic is provided for you. Accordingly, we need to proceed the program. Here, what we want to perform here is you have a 5 data. Start, that is the internal RAM. The memory location is 40H. Okay, so the 40H, let me say it hold the data of A5. 41, it hold the data of 0F. And 42H, it hold the data of F0. And 43H, it hold the data of 33. So CC hold the data of 44H hold the data of CC. Okay, so this is your address and this is your data. Okay, so what we need to do is, so this is your RAM, right? This is your RAM. So we need to send this data to external RAM, that is external RAM. Okay, external RAM we need to send. So the address is 3300H. So 33001. So 33002, 33003, 33004. So these are the address where we need to send the data from internal RAM to external RAM. So this is a 16-bit address. So this is external memory. So it is connected with the 16-bit address. Okay, here main thing before starting the program, see this is a instruction move x at dptr comma e. See here move x. This x determines it is a instruction used to send a data from internal RAM to external RAM. This is a instruction coming under indexed addressing mode. Okay, suppose if I want to need to send a data from read-only memory, that is a ROM to external ROM. So you want to use here move C. So that is a important thing you need to understand. Okay, so we will proceed to the program now. So I will put the table for easy understanding. So org starting address of the program. So this starting instruction of the program. So move R0 comma hash 40. This hash determines immediate value that I am transferring to the R0. Okay, so let me say I will put the table R0 now hold the data 40H. Okay, now after execution of second instruction, this is the output. Now let me go for third instruction. Now move dptr hash 300H. Now after execution of this instruction, the dptr will hold the data 3300H. So here you need to understand this is the internal RAM, this is the external RAM. Okay, this is the address where we need to put the data. Okay, now so this 3 instruction, I think you are clear. Now we will go for fourth instruction. Move R2 comma hash 05H. So I am transferring immediate value 05 to R2. That means this is used as a to check the number of values. Here how much data I need to send? 5 data. It is something like a counter. So it will keep on decrement and it will count the number of values you are sending mutually. Right. So initially we are sending 05. So now after execution of this fourth instruction, the data will be 05 in the R2 register. Now so we will go for the fifth instruction. So this is a label loop move A comma at R0. So this is an address in at R0. See, this is a 40. This is a register R0. What is the at R0? Is A5, right? So let me write here for a clear understanding. A5 is the data which is available in at R0. that to be transferred to A. This is a data transfer instruction, right? So now currently the A hold the data A5, right? Now I want to take a complement and I want to save in accumulator, right? So what you need to do now, the current data is A5. If you take complement, you will get a 5A. Why we are doing so? The reason is, read the program. So I have a data in the internal RAM 40, 41, 42, 43, 44. That is a 5 data. These are the address, these are the data. So I need to take a complement and I need to transfer those data to external RAM. So that's why I am doing a complement here. Now see, after taking a complement, I am sending this accumulated data to at DPTR. What is at DPTR? You know that this is the address, right? This is the address. So what is the, in the address, what is the data I need to pass is, so here see the accumulated data. What is the accumulator now? 5A. The 5A, it will go to the DPTR. What is the DPTR address? DPTR address is 3000, right? So now 3000 will hold the data 5A. So now logic is performed, right? So this is what they ask. So we need to share the data, transfer the data from internal RAM to external RAM with the complement. So this is a internal RAM and this is external RAM. See, you can see it is a complement of this number. So in this way we need to transfer 5 block of data. Okay, now let me go for the next instruction, increment R0. If I increment R0, what you'll have? You have a 41H. Then you want to increment the DPTR also. So 0001H. Now see the D J N Z. What do you mean by the decrement and jump if not 0? So what is the current data of R2? It's 5. It is not 0, right? So you need to jump. See, decrement, you want to decrement. So let me decrement. So this is 0 or no? It is, you want to jump if it is not 0. It is not 0, right? So then I want to jump. Where I need to jump? I need to jump to loop. That's it. See, decrement. I have decrement from the current value. Then I want to jump. If you don't have a 0. So 4 is not a 0. It's not equal to 0, right? So then I need to jump, right? So this will be in the loop up to 4, 3, 2, 1, then 0. Once it get the 0, it comes out from the loop and end the program. So this is way. So we now will go to the loop, right? Now it decremented to 4. Now it is going to loop. Now the at R0. What is at now? What is the current address of R0? 41. So in 41, what is the data now? 0F, right? So 0F will go to accumulator. So the current data in accumulator is 0F, right? Okay, so first this is second looping process. So now the content of R0 is updated to accumulator. Now you want to take a complement. If you take a complement, so you will get F0 that is stored in your accumulator itself. Now the content of accumulator I need to pass to at DPTR. What is at DPTR? 3000 is your address, right? Then I need to, in that specific address, I need to send the data F0 into that address 33001. So that means currently so 300 will hold the data 5A. For execution of, after execution of this instruction, the 3001 will hold data of F0. So you can see here A5 5A, 0F F0. It is the complement. So this is a after the next execution, right? Now you want to increment the R0, right? So F2H, then DPTR 3002H. Now I want to decrement this R2. So it is 0. No, it is not 0. So then I want to go to the loop again. And what is the content of R0? What is the content of R0? F0, right? So F0 will go to A, right? So currently will hold F0. Now, so that you can update here also. Okay, now after execution, this is the output you will get, right? Now you want to take a complement. If you take a complement, right, so where you need to save in same accumulator, right? So you will get a 0f, 0f, right? Now after this, the content of accumulator have to share to the external RAM location, that is at DPTR. What is the current memory location? 3002. So that means you have a data 0f. Okay, now you can update here also, so 0f. So then so again what happened, your increment R0, so 43, so this will become 33003, this will become 2, it is not 0, so what is the next data? 33, right? It is a 33. Now that, so that will come to accumulator also. Then you want to take a complement, so if you take complement you will get C, right? If you see 8421, so 0011, 0011, this is a 3, 3 3. If you take a complement 1001100, so you will get CC. So you, after updation of this one, the accumulator hold CC, right? So you are complemented and stored in accumulator. Now that data have to transfer to the at DPTR. What is at DPTR? 3003. So now currently it holds the data CC. So here also you can update. So then next last process. So there is a increment your R0 44H, DPTR 3004H. Now decrement your R2, it is not 0, so keep on doing. So at R0, what is the data? CC. Okay, so your accumulator will hold same. Then you want to take a complement. If you take complement of CC, you will get a 33, right? So that is stored, that then it is transferred to, by using this instruction it is going to this DPTR at DPTR. So currently, so 3004 hold 33H. So now everything is updated. So now you can see here again I will update 45, then 3005H. But if I reduced R2 1, it will decrement 0, so the condition fails. See, decrement and jump if not 0. So if it is not 0, only have to jump. So this is equal to 0, right? It is equal to 0. So that means the condition fails. You have to come out from the loop and end the program. So this is way how the program is working.